Explain that a
bell
medium
jar,
is, huh?
bell jar experiment.
Yeah. So explain that a medium is required in order to transmit sound wave. Then speed of sound will be different in air, liquid, and solid. So
When air is present, you can see the striker hitting the bell, but then
yes,
you still can hear the sound.
yes,
When air is removed, you can see the striker hitting the bell,
but
but
no
the
sound.
sound becomes fainter. Then when
Becomes
there is no sound, you can see the striker hitting the bell and there's no sound, and you cannot
yes,
hear the sound.
yes. There is different permutation to this question. Say they'll ask you why do you use thin wires, and then the electric bell is freely suspended. So then you will say that use very thin wires so that the transmission of sound will be minimized because the sound can travel through the solid. So if your solid is very big piece, right, then the air would the sound will go out via the transmission through the solid. Then it's hung in mid air like that, right? Is because you don't want it to come into contact with the table.
with the with the glass,
Yes. So
with
when
the
it
jar.
comes when it comes in contact with the table or with the glass or the bottom of the setup, sound can come out, can be transmitted via the table. If it's closed, if it's stuck on the bell jar, right, the glass, right, then the sound will be transmitted via the solid glass. So you cannot let them happen. So you hang it in mid-air like that and it's not in contact with anything. And then you use very thin wires to so that every possible transmission through another medium will be eliminated.
But then it can still travel through the wire.
Yes, so that's why you use thin wires to minimize the transmission. So
In
if
theory, you would not be able to hear the sound, but really,
you
but
may hear a beat,
practically, because it can travel through the wires.
yes. Then through the wires, it will go to the glass. So you can only minimize, you cannot totally eliminate. So it is so if there is if there's a question, there's a test, then they ask you why does someone after don't know doing all this, right, still can hear the sound. So then the possible reasons why you can hear the sound is because either through the wire, or if it's stuck to the bell jar, then it's through the bell jar solid, or if it's landing, if it's placed on the table, then it's through the table. But theoretically, you should not hear anything. Okay. So since you have described that experiment to me in a very detailed manner, so I'm not going to read whatever I wrote because whatever I wrote down here is whatever you said just now. Okay. Agreeable?
Yeah,
So we have some information down here. You have speed of sound in solid, liquid, and gases. So you see that in solid, the speed is in steel, right, 6,000. In water is 1,005 meters per second. In air, right, 330. So from this data, you tell you that the speed of sound is the fastest in solid, slowest in
and the
air.
slowest in gas.
Yes. Why it's faster in solid is because their particles, right, are very, very close together. So they can vibrate, their vibration will be, and collision with the neighbors, right? Neighboring atoms and particles will be very efficient. So that means they will transfer the sound wave more effectively. Then liquid, same thing. It's also because the particles are close together, but because they are not as close as the particles, how particles are arranged in the solid. So that's why the speed of sound is a little slower in water. Then of course air, because air particles are very far away from each other. So it takes even longer. And this is also a reason why if you want to eavesdrop on someone in the next room, you will put your head near the wall. You know what I mean?
Yeah,
Yeah, if you want to, I mean, in certain movie shows, they would like say there will be certain scenes where they say they want to kind of listen to what the neighbors say. Then they would have this practice of putting their ear on the wall because it's easy for the sound to travel through the solid wall. Okay, enough said. Okay, question 3A. You have a diagram, shows a loudspeaker inside the bell jar. Okay, then the speaker is connected to a vacuum pump. The lightweight object is suspended next to the bell jar facing the speaker. Then the speaker is turned on with music at maximum volume and the vacuum pump remains off. Then what happens to the lightweight object? So what would the answer be? Will move as sound travels fastest in solid, and they ask what happened. What happened? Do we need to explain it?
No.
So it say what happened, what will happen to the lightweight object. So you don't have to explain it, you just say what happens to it. Whether it moves or it doesn't move, or it swings or it doesn't swing, or it remains the same. Because they only ask you for what happens to it.
Lightweight object will move back.
You can say it will move backwards or it can swing left to right. You don't have to explain why the sound travel faster in solid. Those you don't have to explain. So you only need this, and then what kind of movement is it? Left to right or right to left or up and down?
Front and back.
Yeah, you swing back and forth, left, right, or up, down. You explain that. So the rest you don't have to. These are all not required because they say what happens. They never ask you to explain why, so don't explain. Because when you write more, right, the more you write, as in down here, right, you write anything that is out of what they want, right? If you write anything wrong, right, then you're asking for trouble. Okay, so how do the air particles around the lightweight object move due to the sound wave produced by the speaker? How you will move? So how they ask for how the air particles move. So you say it will move with compression and rarefaction. Then you have to then explain what is compression and what is rarefaction, because they ask you how the air particles move. And you stating compression rarefaction doesn't make a lot of meaning unless you tell them what compression and rarefactions are. So what I have here is you say that the air particles are pushed together and pulled apart in horizontal direction. So push together is your compression, and then this pull apart is your rarefaction. You can just tick your answer, then you're fine. Okay?
Yeah.
Hence, state the type of wave the speaker produces. Careful of the spelling. Okay. Then now this is the second part, the part B. So now we still have the loudspeaker placed inside a bell jar. Then the speaker is connected to a vacuum pump still. Then the lightweight object is suspended next to the bell jar facing the speaker. The vacuum pump now is turned on. So volume is at max. So what do you think about how does it move? Yes, it stops moving. That's right. Okay, then second part, I say what can you infer from the observation? So it's more like why does the lightweight object stop moving? Do you want to check your answer? So you will write and then you read through and you will check for all sorts of mistakes. Okay, the frequency of a sound wave is 250 hertz. What is the wavelength of sound wave if speed of sound is blah 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 blah? Units, meters is correct. So your speed is in meters per second. Frequency will be in hertz. This will be so if this is not in meters, then your speed, the unit will not be in meters here.
EM.
Yeah, then you will need to do conversion for the 330. So it's best, right?
Then is
Because
there a chance that they will ask for the answer in cm per second?
no, they usually don't, but they will twist this and make your wavelength in centimeters. Then you would have to change your units.
Then divide by 100.
Yeah, you have to times 100. So it's very seldom very seldom that they will do units conversion for this one. They most likely will do unit conversion for the wavelength. If you use centimeters for both, it's fine. It's just not okay if your left hand side and right hand side become a different unit. Then you will run into your calculation, your answer having a lot of decimal place problem. Like you see that your answer is either too many decimal places off or too little decimal places.
Will they give the frequency in any other unit?
Frequency is only in hertz, or they will give you kilohertz or
1000
megahertz. So this is
kilohertz is 1000 hertz.
yes, then this is 1 times 10 to the power 6 hertz. Then it comes to a matter of prefixes, because there is prefixes in the first chapter of physics. There is also prefixes in your indices chapter for your math. So prefixes can be used in physics. So those prefixes you need to remember the value. Next one. Now they're gonna try to be funny with you. The speed of sound is this. Then the boy is 8 kilometers away. Then calculate time taken. So do you still use the same formula?
No, speed of sound equals to 2 distance times time.
2 distance over time.
Because got the echo.
But question here is, right, you have to read properly. Is this an echo question? So the story says like this: you have the boy, okay, then it is standing from a place where the lightning discharges. You have the cloud. Then they say that he is standing 8 kilometers away. Then the speed of sound for this to come here, the speed of sound is 0.240 km per second. So is this an echo question? So do you still use speed equals to 2D over time? You must always read carefully, don't jump to conclusion. Why no 2D right now? Why isn't there a 2?
Because it's not an echo question.
Yeah, because you see that the sound only travel in one way and not two ways. I mean, not to and fro. The sound only travel directly. Look carefully at your answer. Look carefully. Have you spotted the mistake yet? Think carefully. This is not a physics problem right now. This is a math problem. Yeah. What's the unit? Okay. So you notice it's a cross multiply on here. Next one. Okay. So this may be a bit extra. This may be a bit of extra info. So sound, the speed of sound in air, right, can be affected by physical condition. Physical condition, that means you can have pressure, temperature, humidity. These are all physical conditions. So temperature the speed of sound is proportional to the root of temperature. You don't have to exactly know it's the root of temperature. You just need to know that the speed of sound will increase if the temperature kind of increase. I don't think it's required for you to explain why the speed of sound increases when temperature increase. You just have an idea of it, that will be enough. Then if humidity increases, the speed of sound will also increase. Do I have to explain what is humidity? It's from the thermal property chapter. Then pressure will not affect the speed of sound. So why temperature increase and humidity increase will cause speed of sound to increase is mainly because one, particles have more energy, so they move faster. Then two, because there are more particles, so vibration of the particles in the medium will also increase, so they travel faster in that way. But you don't have to explain that.